Steve was all like, come on in, man, test some coolers, it'll be a good time. Yeah, it'll be fine. Just slap it on the bench, have a sody pop. I've been in here for 3 hours and I haven't even turned the computer on yet.
So the Arctic Freezer 50 has some flaws, and before anyone says, but that's part of the design is flawed. So this is a $75 air cooler. It's following up a lot of reviews we've done recently of liquid coolers and of really positive reviews for Arctic's other product lines, their Liquid Freezer 2 series. And we've also tested some air coolers in the past. So on our charts, we have things like the NH-U14S, the NH-U12S, the D15, of course, the Assassin III, and then we've got a couple of other competitive air coolers in there in similar price categories to this one or cheaper, like the FUMA 2. And today we're going to be reviewing the Arctic Freezer 50, not the Freezer 50 TR, the Threadripper edition. This is the one that's intended for AMD Ryzen or Intel heat spreaders, not for the AMD Threadripper heat spreaders. So this is what we're going to be looking at, including the dremeling that we had to do earlier. Before that, this video is brought to you by the Thermaltake Tower 100. Thermaltake's Tower 100 is a mini ITX case to serve as a showcase system for your components. The Tower 100 has received many revisions since we first saw it, and the case now has an open vent in the bottom for intake, a mesh cutout in the side panel for some GB ventilation, and additional mesh along the side skirts and the side panels of the case. The Tower 100 is mostly focused on building a showpiece PC that's small enough to fit on most tables. Learn more at the link in the description below. We've learned over the years that people really like to have their purchases justified, so I know that some people are going to say, well, but you don't have to Dremel it if you use the right RAM. And the thing is, this cooler, so we'll get some closer up shots of it and go through some dimensions later too, but basically it comes down to a point on the front, and it's completely unnecessary because the fan doesn't extend that far down, and so that point is really only there for looks. But you can't see that part of the heatsink when it's installed in any computer. So it ends up being pointless and unfortunately restricting the RAM selection. And the cooler restricting the RAM selection when most of the RAM on the market has some kind of slightly taller heat spreader or RGB topping on it, it's not really a place you want to be if you're a cooler manufacturer, because people are going to just pick a different cooler. There are a lot more coolers out there than there would be high performance RAM with absolutely nothing at the top of it, at least not stuff that's been recommended regularly online. And people are more afraid, I think, if they're a new builder, to select the raw memory than they would be to just, well, let me just buy a cooler that I know will fit. That just seems easier. So unfortunately, that does end up restricting the market for this thing in a way that it doesn't need to be restricted if it had been redesigned a little bit differently. But we're still gonna look at it. We did have to cut the bottom off to fit our standard test bench. We can't just swap the memory on our standard bench because then it's not standard anymore. So we decided to just modify this. It did not modify the airflow, just the fitment. So we don't have any issues where the fan itself doesn't have a piercing through the bottom. It's just the extra plastic shell. Now, to Arctic's credit, it does acknowledge this issue. It says on its website, quote, since the Freezer 50 is built for maximum performance, including a massive heatsink, it does not have limitless RAM clearance. Recommended is a maximum memory module height of 37.5 millimeters. This stipulation is mainly due to the tip on the underside of the Freezer 50, which means modules that exceed this height could still be compatible if they have V-shaped or centrally recessed heatsinks. So that's reasonable, and it's good that they make it obvious that it's not necessarily going to clear, but most people probably don't measure their memory. They just take a guess and go for it. In this instance, there are only a couple modules that have recessed centrally designs, like some of the ADATA stuff, for example. But as for the excuse of it's built for maximum performance, including a massive heatsink, the heatsink's big, but the heatsink's actually not the problem. The problem, again, is the completely excessive plastic on the heatsink. It makes it black and silver, which is maybe what they're going for, and RGB, of course, but it is excessive. It doesn't need to be there, and so that's the actual problem. Okay, so let's get into the review. We're gonna be testing this versus everything else we've reviewed recently, but at $75, this lands between the FUMA 2, which reviewed well in our charts at, that's a $60 cooler, and maybe the Assassin III, the D15 stuff that's about $100. Then, of course, there's the liquid coolers at the higher end on the charts as well. Time to talk product mechanics. The Arctic Freezer 50 cooler runs into clearance issues with RAM and large I/O shrouds, and RAM in particular will be a collision point almost anytime RGB or tall heat spreaders are used. The end result is a plastic shroud that completely needlessly collides with memory. And by needless, we really mean it. We cut the shroud down with the Dremel without needing to cut into the actual fan airflow channeling. This allowed us to get clearance, but still keep the air path unaffected. This demonstrates the unnecessary compatibility limitations as well. The plastic surrounding the exterior fan can be reduced, and the plastic around the exhaust side of the cooler could mostly be removed. For the front side, near the RAM, it comes to a point as sort of a design motif, but you can't actually see or appreciate that externally, so it serves no purpose other than to pointlessly eliminate a large selection of the memory compatibility pool. In an Intel system, the cooler can be mounted for horizontal or vertical airflow patterns, while an AMD system only supports horizontal airflow. The horizontal airflow options are where the clearance issues are prevalent. The vertical airflow orientation for Intel provides appropriate clearance, unless you're using a rotated dartboard or something, but then the GPU clearance becomes a major concern. With a vertical orientation, you're going to pull hot air off the backside of the GPU and straight into the cooler, and the air from the front of the case now has to start making 90-degree turns to get into the cooler to begin with. This is generally not advised as an orientation for any type of CPU cooler. The front and back shrouds of the cooler have a narrow 39mm clearance from the surface of the motherboard. From the cold plate to the rear edge is 61mm, and from the cold plate to the front edge, it's 68mm. The cold plate is 28 by 36mm, with the narrower dimensions aligning with the direction of the airflow. Total height is 166mm, and the interior fan is 140 by 27, so it's technically about 2mm thicker than usually. The front fan is a standard 120mm fan, and both fin stacks are 102mm tall and 140mm wide, with some variation in the width for air funneling. The front fin stack is 28mm deep, and the rear fin stack is 46mm at the center, and it tapers down to 34 on the sides. The fin stacks are connected to the cold plate by the obvious 6 heat pipes. Installation on AMD and Intel systems starts the same way. The interior fan RGB assembly must be removed in order to gain access to the cold plate screws. This is the most difficult part of the installation procedure because the tabs at the bottom of the fan RGB assembly have to be pulled away from the fin stack to release the locking mechanism, but the plastic has very little give, and as is a trend with this type of plastic on a cooler, it's excessive. For an AMD system, the stock plastic mounting brackets have to be unscrewed and removed from the motherboard. AMD-specific standoffs are then threaded into the backplate. 2 Arctic mounting brackets are next fastened to the tops of the standoffs with small thumb screws, and the mounting brackets need to be oriented correctly for the socket you're working with. The holes will support the incorrect installation if not paying attention. Apply thermal paste after this, place the heatsink on the mounting bracket, and align the captive screws with the mounting bracket holes. And next, it's just spring tension screws to thread it all in, using the usual alternating pattern to maximize the tension, and at that point, the fan RGB assembly is just dropped back into place. When doing that, you have to pull the edge tabs at the bottom apart while pressing down to lock the assembly into proper alignment. Otherwise, it's going to be loose and it will rattle. You can connect the fan and the RGB wires to the appropriate headers, and it's pretty much done from there. For Intel, the main difference is just placement of adhesive washers on the top and the bottom of the CPU socket through holes alongside the Intel-specific standoffs. Time to take a look at pressure across the surface during installation. This is tested using chemically reactive materials and a special NIST traceable scanner that we have and that we could only afford thanks to our Patreon behind-the-scenes backers on patreon.com/gamersnexus and our GN Store supporters. Thanks to everyone who visited store.gamersnexus.net to grab a toolkit, mouse mat, or other item. The pressure scanner came back with the 3950X mount looking overall evenly distributed. The top of one mount near the VRM and the bottom of the remount near the RAM show slight areas of low pressure. This is more indicative of the mounting hardware and that solution than it is of the Coldplate Flatness, which we'll look at separately. There's one really interesting thing going on here though. If you look carefully, you'll see that the mounting hardware itself is connected to the IHS. The heat pipes are distinctly outlined in the pressure map. But if you look at the outer edges, you'll see the mounting structure for the heatsink contacting the IHS as well. This isn't necessarily bad, it's just going all to metal anyway, so it's better than nothing, but it reveals 2 interesting points. First, the effective heatsink area is smaller than it appears here. This isn't actually full coverage. Secondly, the mounting bracket on the outer edges, outside the heat pipes, is contacting the IHS with higher pressure than the heat pipes themselves. This is suboptimal, as our most effective area of the cooler has less directly mated than the mounting components. The 3800X testing shows the same thing, so this isn't just from one IHS. We'll start our thermal testing with noise-normalized benchmarks at 200 watts. This uses the included fans on each cooler, but sets them all to the same noise level to disallow coolers brute forcing to the top of the charts. This allows us to control variables for a proper like-for-like comparison, and you can check our methodology piece linked in the description below for more information on how all of this works. The Arctic Freezer 50 ran a CPU load temperature of 62 degrees Celsius above ambient in this test, ranking it actually worse than the Corsair A500, which was among the worst coolers we've tested. It's just ahead of the Ninja 5 at 34.4 dBA with the FUMA 2 fans, and the Ninja 5 didn't review particularly well with us either. The FUMA 2 outdoes the Arctic Freezer 50 by more than error, and at the time of writing is about $15 cheaper than the Arctic Freezer 50, plus or minus 5. All other air coolers we've tested at 35 dBA are outperforming this one, with the Freezer 50 only outdoing the Ninja 5, stuck at 30 dBA, and at 34.4 with different fans. VRM thermals aren't critical to this type of test, but still useful for determining where the air is going when passing through or around the cooler. For our 200 watt heat load, the Arctic Freezer 50 ends up just above the midpoint on this chart. The hottest MOSFET is 44 degrees over ambient in the Freezer 50 tests, ranking it alongside the liquid coolers and below only the NH-D15 from the air cooler category. Arctic's design has more air moving along the sides and more air pushed lower along the cooler than other tower cooler designs we've tested thus far, again aside from the D15. The common point between these is that there's a larger fan, and this larger fan covers more area along the board and especially below the bottom of the tower, which is where the air is able to get to the VRM. Now this isn't particularly useful for our test setup, since we're well below spec with even the hottest of the results on this chart, but it helps understand a strong point in design, namely the strong point of having a larger fan in the tower. If you're in a really restrictive scenario, you're using maybe a worse motherboard and trying to push a higher overclock, then it starts to become meaningful or valid. But here, again, we're so far below spec that none of these results really matter for differentiating anything other than what's the relative performance if you were to end up in a more restrictive scenario. Moving on to the 200 watt heat load at 100% fan speed, we now unleash the coolers and let them run at their max speed. This means that we've no longer controlled for noise, so a variable has been added to the mix. This data would be useful to anyone who's okay with setting fans to 100% speed and walking away. Maybe for the best in some cases, like the 60 dBA result of the EVGA CLC 360, which basically necessitates walking away or living on a different side of the country. It's really loud. The Arctic Freezer 50 ends up in the bottom three. Its maximum speed, averaged between the two fans, has the noise at about 42.2 dBA in our standardized noise testing setup. This makes the Freezer 50 similar noise level to the Liquid Freezer 280 and 7 degrees warmer. That's liquid versus air though. For another air cooler, the Noctua NH-D15 runs at 43.9 dBA in our environment for 55 degrees over ambient. Comparatively then, the Freezer's result is expected. It's among the quieter coolers on the chart, and only the Ninja and the FUMA 2 run warmer, both quieter than the Freezer 50. The FUMA 2 demonstrates the extreme inefficiency of the Freezer 50 at full speed, because we're only climbing about 2 to 3 degrees for a reduction of 8 dBA. That's a significant noticeable change in noise. The next test is for cold plate flatness. As you'd expect of a cooler without a flat cold plate, we can see the dips in the surface as it gaps from the IHS to the deepest groove between the heat pipes. The Freezer 50 had several measurements above 200 microns, with a couple of spikes at about 396 or above 300. We had to expand the scale of this chart in order to even accommodate those spikes. So it's definitely blowing out the scale compared to the previous loser of the A500, which was the worst on the chart. This is expected to an extent with exposed heat pipes, and it doesn't inherently mean a design will perform poorly, but combining this with the test data that we showed previously, we can now support some reasons why this cooler fell so far down the charts. With a flatter surface or minimally mounting pressure in better places, this cooler could climb a few ranks in the air cooler listings in the least. With a close-up shot of that cold plate, you can see exactly what we're talking about. Like most other coolers that don't have a flattened contact plate, there are natural gaps between one heat pipe and the next, and those gaps get filled by thermal paste. You can see all of this in our shots, but we'll chip some of the paste out to make it clear. It's okay to have gaps between pipes and to fill it with paste. That's the job of the thermal paste. This cooler doesn't have anything else to make up for the inefficiency though, and that combined with some interesting mounting pressure results explains the ranking. Reducing the heat load will eliminate most scaling on the charts for high-end coolers, as we've explained before, and it'll make them all look the same. That's because there's just not enough room for them to be different, so they sit there spinning their wheels, and everything at the high end will be within 1 degree or so of each other. This is, however, useful for looking at lower-end coolers. The Noctua NH-D15 pops up on this chart because it's just not enough to run the 200 watt heat load. This is running again at 35 dBA, and it's on a 125 watt R7. The NH-D15 is a single fan tower that runs about 3 degrees warmer than the Freezer 50. The Freezer 50 ends up around the NH-U14S, which is a 1x140 fan, for the performance results on this 125 watt heat load. This is why all of that Coldplate pressure and flatness data is useful. It's easy to explain why the performance of a dual fan cooler is worse than that of a single fan, single tower cooler when we know the overall poor combined pressure distribution and cold plate depth. That's the source of a lot of the performance positioning of the Arctic Freezer 50. Closing out then, it's not really worth it thermally. This cooler, even ignoring the plastic ensemble on here, it's just not a very strong thermal performer. It's fine. It's not like it's crazy overheating or anything like that, but it's not competitive. And you should basically be buying a FUMA 2 for a little bit cheaper or a different cooler. This one has some interesting issues. It's been useful for us because it's allowed us to sort of showcase some of the testing we do, where when we take the depth measurements of the bottom side and when we take the pressure measurements, you can see those things together form the inefficiencies that contribute to its performance that's not even middling, it's just sort of at the lower end of the charts. So mixing the height discrepancy in the cold plate surface with uneven pressure, well actually it's not even uneven, it's just strange, where they are basically leveraging part of the mounting bracket as part of the heatsink when really the cold plate should just be larger. This isn't, so this is aluminum. Ideally it would just be a larger copper cold plate to get full coverage instead of using part of the mounting kit, especially since when you tighten these screws down on the bottom, the way that it tensions and torques and sort of contorts the plate a little bit, you end up with more pressure on these outer edges than you do on the copper heat pipes, and that's a problem. The copper heat pipes should have the best contact. It's the most direct cooling solution, and so some changes to the cold plate design, Arctic could probably have a much more competitive solution. But that's it for this one. Thanks for watching. As always, you can subscribe for more. You can go to store.gamersnexus.net or patreon.com/gamersnexus if you'd like to help us out directly or get bonus footage or some of our toolkits and mouse mats. And we'll see you all next time.
Do you think they'll take our return?